This is an LACTO Forum production.
Welcome to Exception Handlers. I'm Alex.
And I'm Bill.
And this is first episode of season 2. We're very excited to be back. And this first episode is going to get kicked off by us talking about a really interesting panel that we were both on last week around AI metrics. Before we get into it, do you want to tee this up, Bill?
I think that 2026 is going to be very interesting. And this is the tip of the interesting iceberg as we're seeing it. It's clearly information that came about as a result of what happened in 2025, but there's a lot of signal here that's showing that 2026 is actually where we're going to see the traction.
It is a pivotal year. There's clearly something in the air. There's clearly stars aligning. So let's get into it. So this just to set this up, this panel was really around AI metrics, but really more broadly, how are you getting your handle on using AI for software engineering in 2026? What are all the things that need to happen? What are all the things you need to think about? And just to start off, kind of the first big topic that was addressed was there is no question that the AI productivity revolution is actually here. This isn't, finally. This isn't like, hey, it's coming. Maybe tomorrow something amazing will occur. It's here. It's being used. It's having results. So just quick summary kind of the details on that. 90% of engineers are using it, and organizations that are using it are seeing 35 to 40% productivity improvements across the board. Not hype. It's a measurable reality.
And I think one of the things that's really interesting to me is that on the tech side, we're starting to diverge a little bit from the rest of the world, quote unquote, because I believe on the tech side, we're able to do things that are measurable, at least to the extent of being QA level, that are very consistent with how we've done things traditionally in the software world in the past, which sets us apart from people writing letters and doing other things.
Yeah, I mean, software development has always been a fairly, I don't want to say predictable, but like there's a structure to it. There's a cadence to it. You can use different tools that make you go faster, but fundamentally the structure doesn't change, which allows you to actually measure current state and have a meaningful comparison to yesteryear and see that there is a difference. There is an impact.
And there's still, even though AI is amazing, there's still a number of mechanical aspects that go on that have been traditionally measured and watched and meted out in a very discrete process that was software engineering.
Yes. And so I guess moving on from that, in terms of kind of the next big topic that people talked about was measuring. And I know we're going to talk a little bit more about this later, but just to tee this up, it's clear now that measuring AI productivity is possible, and it's because measuring engineering productivity is possible. And I would argue, for the first time in my lifetime, I cannot tell you how many conversations I've been a part of over the past, I don't know how many decades, with people about, hey, how do you measure engineering productivity? We have tried and tried and tried again.
And it's clearly the case of trying to build a better mousetrap when you're working with a bunch of mice who have the ability to modify the rules of the game very quickly.
Well, I mean, let's just kind of maybe mention a few things that people have tried and talk about how gameable those things are. So lines of code, right? The old classic. As soon as somebody realized I could just write abstraction over abstraction over abstraction, and suddenly factory classes became a thing, and suddenly lines of code became a completely meaningless metric. Yep.
Yeah, it's one step above diff.
Yeah. And then, of course, the other old favorite, story points. How many estimation poker sessions have you been part of where people were just coming up with numbers that maybe meant something to them, maybe not, certainly didn't mean the same thing to different people, and then trying to put that into some context and assign some meaning and some historical value to that. That is such a difficult thing to do well.
That, and again, coming back to your lead engineer and you're asking, what have you been doing for the last 2 days? And the answer has to some sort of, well, I've been working on the points thing you asked me for because product's over here jumping up and down and we need this for our stories.
And it's not just product, right? Ultimately, all of this is there because somebody at high up top says, what are you guys doing? How productive are you? And more importantly, are you as productive as you should be? Or are you as productive today as you were 2 days ago? Or are you going to get more productive tomorrow? Like, that's why all this exists. And that's why that traditional conversation has always been, my goodness, I guess we can measure something, but I don't know how meaningful it is. And it's notoriously difficult. And there's all this nuance and blah, 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 blah. And before you know it, people just go, you know what? You guys don't know what you're doing, clearly. This is all just made up stuff. But there's now this really interesting thing where you could have AI help you measure productivity meaningfully and kind of independently of all kinds of variables that normally are a big confounder. And we'll talk about that more. But like this whole idea of metrics and measurement really resonated with me.
Yeah, same thing. It's the ability to quantify the unquantifiable that we're actually starting to see.
The other thing that came up here that I thought was really interesting was there were a lot of concerns, and I mean, recently, right, where people are like, man, AI slop, it's going to generate a bunch of crap and it's just going to destroy your code base. And, what are you doing? How could you be letting AI just write your code? Turns out, if you actually measure it with proper guardrails, quality concerns are not a thing. There's just no, at least from the companies who spoke up and shared their real world data, the kind of consensus was there is nothing inherently more risky with AI writing code in terms of quality if you have proper guardrails, which is a common theme.
Yes, and I think the proper guardrails are carbon based. I mean,
aided by process and tooling.
Yeah, well, absolutely, but it's the carbon based elements that are working with the different tools. And your digital pair programmer is one of those tools that's not submitting things for production or final QA testing that they know has fundamental flaws or hasn't at least been cursory checked by them to make sure it passes relatively reasonable number of sniff tests.
Exactly. Which, by the way, I think transitions nicely into the last topic, which is there is no question AI could be valuable and can really impact productivity, but it isn't magically or organically going to do that. You really have to have some focus and discipline around how you're using it to make it as predictable as possible and as reliable as possible. And that's a big thing that came loud and clear in this conversation.
And this is the one that, for me, really started ringing the bell because I've been watching a lot of the interactions with the various groups and CTOs and teams talking about stuff about how to get the teams on board and get the organization on board and how to bring everything together so that, AI can help solve whatever problems we're doing. But at the end of the day, my concern always rolled back to how are you going to be able to do it in a way that's reproducible and dependable, et cetera? And I've always thought that, team size has an effect on this and the ability to have, again, the carbon units involved to go through and make sure that there's a sane process being carried out. And it's amplified like crazy by AI, but it's still the meter and tempo of what happens and the checkpoints to make sure that things are okay as they process through are handled by people who know what they're doing and understand software. Because at the end of the day, this is going to have to run somewhere. And I don't care what magic tools you got it out there in the cloud, you're going to have to support it.
Yeah, absolutely. So, okay, I think this covers kind of conceptually what was discussed fairly well, but I do think there's a couple of areas that we should do a deeper dive on because I do think there were a couple of standout gem ideas for me in this conversation that I really want to dig deeper on. So the first one that came up was this, and we talked about this already, but this idea of measuring productivity. There's one of the companies that presented, they have this concept of looking at PRs and evaluating PRs on a bunch of sort of metrics that can quantify how valuable those PRs are. Not necessarily how much work went into them, although that potentially plays a role in quantifying value, or at least value per effort, but like how risky were they? How big a change was it? Were there lines of code deleted versus added? And is that one better than the other? Did you simplify things? Did you add tests? Did you create interesting and complex algorithms? Did you add some critical business value, right? So like imagine a system that could look at a PR independent of stack, independent of team, and tell you, here's a number you can assign to this PR that, based on a bunch of parameters, tells you how valuable this PR is. And imagine doing that consistently over time in a way where you can actually compare a given team's productivity to a different team's productivity, and then understand the differences and why that is. Compare the same team last year versus this year. Compare the impact of tools like AI. Are you getting more value through the system? I just think this concept of dialing into a PR as the unit of measurement of value is really, really interesting if it can be done without bias, or without too much bias, and without too much ability to game.
And along those lines, I think you really touched on it with the word consistency. There is no objective scale in the universe that we can use. However, if you have a consistent process that uses consistent tools with a consistent vernacular to look at consistent measurements, now you can go team across team, team over year, person by person, any number of elements, because that creates your own universe of objectivity.
And I think makes it harder. And it also makes it harder to gamify, right? So it's much easier to fake lines of code or to make up some nonsensical story points than it is to tell an LLM based on real diffs from a real PR that you're just trying to get a job done to gamify it, to make it easier, to better or worse, more or less valuable.
Well,
I think it's hard to do.
Exactly along those lines. If you start introducing, I don't know, a dozen different vectors, and you've rattled off a bunch of them. The other one could be simple, scale of functionality.
Right.
There's a number of functions. It just doesn't matter. What really comes down to is if you have all these different vectors for looking at and measuring, over time you can build up whatever your baseline is, and you can start looking for departures from baseline and act however you want. But it creates your own level of a standard.
I'll do you one better. You don't even have to wait. You could just grab all your PRs from last year, run this thing against them, give you an initial sort of baseline, maybe vet it, maybe even iterate on the prompt for your team. Like, I can completely envision that you could say, hey, whatever, there's a generic sort of way of prompting the LLM, but for our team, we care deeply about security or database performance or whatever. So give that more weight, Claude or GPT 5.2, because that's really important to us. And our value has such a big, database performance has such a big role to play in our value because of our specific circumstances and our specific industry or whatever, that I actually want you to pay more attention to that than less. I mean, and then you can just say, you know what? I have all the data at my disposal. I just hit GitHub for all of my PRs from last year. I run the LLM against those, and boom, I have my answers.
Yes, I think you could definitely play the time machine game. One of the things that I think would be very interesting and very useful in that is you also put whatever your LLM is in the context of the code at the time when those are being considered, because it's the delta in code that I think you're going to get some really insightful stuff on. Even though it's not lines of code, it's able to go through and say, okay, well, look at what the impact was in terms of, like you were talking about difficulty, risk, things like that. You can look at it from that standpoint as opposed to looking at your modern code and doing it. But yes, I absolutely think you can do that.
Absolutely. So anyway, I just think, just like specifics aside, the fact that there is somehow finally at least a viable way to really objectively and consistently measure engineering productivity, where you can actually make decisions and conclusions that are meaningful off of that data. I mean, my God, like, I genuinely didn't think that was going to happen. Honestly, I thought the difficulty of measuring engineering productivity was so intractable that it's going to be with us forever and ever. And the best you could do is either make up something like story points, or look at something meaningless like lines of code, or something along those lines. This feels like a real game changer to me.
Well, and the other thing it does too is it begins to insulate you from the lines of code itself. So if we go into this futuristic world where AI is doing 99% of all of the coding and everything is some sort of vibe interface, it doesn't matter, because you're still talking about, we need to implement this change. We're using something to do it. Right. We're using something to test it, and it's having these XYZ effects. What does that measure out to?
Yeah, exactly. Yeah. So that's one kind of big gem that stood out to me. The other was this idea that we mentioned about, you can get tons of value out of AI, but it isn't going to happen magically or organically. And I think what the way to think about this is to think about, like, you could sit down with Claude and just vibe code your way through a project or a feature, and that'll give you results. Sometimes it'll give you amazing results. Sometimes it'll give you infuriating results. And it's hard to predict a priori when is what going to are you going to get good results, or are you going to get results? So to me, the idea of sort of maximizing value is reducing, if not eliminating, that uncertainty. If I sit with AI and work through a problem, am I going to get good stuff or bad stuff? And it seems like the consensus that's emerging around that topic is the way to get this consistent value and predictability is to manage the context. And I know we've talked about this a lot already in the past. Context is king, but really do small, digestible changes that you could kind of work your way through as an engineer, so that the system so that the AI agent doesn't lose context, so that you then don't get overwhelmed with massive swaths of files that are all changing at the same time, and somehow to create a mental model to understand what just happened is an act of God. There is this the thing that people are coalescing around, and I think it's best represented by this idea of spec-driven development, which GitHub SpecKit, for example, implements across a variety of agents, is that you need to have some very predictable kind of atomic units of change that are digestible to a human being, whether you're planning or coding. And that seems to be one of the key things that need to happen here for you to get maximum value and predictability out of AI.
I agree, although I have a slightly different take on that. And from my perspective is it's not the context as much, although right now it's the big thing to do whatever you can within a context and flush it and go get a new one and chip away at the stone that way, is the fact that you're taking these tasks down into very specific responsibilities, right? You have things like, or whatever the responsibility, whether it's building something, reviewing something, QAing something, looking something up, et cetera. The responsibility scope is very, very well defined. And as a human, you can very quickly keep an eye on it. Is this thing going south? Whether or not that takes one or two contexts, okay, we can have that conversation. But the fact is that this is supposed to go get some data, and I know what the data is supposed to look like, and it came back and it doesn't look anything like that, or it didn't get it. I understand. There's a problem right there.
So just to say it a little bit differently, but absolutely, the idea is absolutely right. What you want to do is create a process that lets you be able to completely understand what the system is doing at every step of the way, so that you're in control. You want to go as fast as you can without losing control. That's kind of the magic. And that magic comes from tooling and process. It's not going to happen accidentally. Sometimes it accidentally happens. Right? Like, it's totally possible to have a vibe coding session with no planning and sort of just going with the vibes that give you amazing results and you completely in control. But it's not guaranteed.
That's going to regress to the mean at some point.
Exactly. You might win the lottery every now and then, but it's not guaranteed. And so, like, spec-driven development and then things like this, they're all kind of getting at that basic idea. The other thing that I think is really, really interesting that very much ties into this is, if you kind of think about abstraction and levels of abstraction when we write software, it seems like every few generations there's an abstraction level up, right? You start with assembly, and then you move on to C, and then you move on to C++ and other OOP brethren. Then you get into larger frameworks and so on and so forth. And at every level of abstraction elevation, the things you used to do that made you successful in the previous set of abstraction did not really apply. So as an example, if you did exactly the same stuff writing object-oriented programming in object-oriented programming languages as you did when you were at assembly, you probably wouldn't get great results, because problems are different, challenges are different, the way you think about it is different, and so you have to change what you do fundamentally because the abstraction changed. And what we're living through right now is that abstraction level up. We don't have to think in terms of the code anymore. We think in terms of the plan.
Yes.
And therefore, you need to do things that optimize for that, because that's what makes you successful. And I think, again, spec-driven development, things like this, they really let you focus on the plan and make it so that it's easy for you to understand the plan and comprehend the plan and review and approve the plan. And so that when that plan translates into specific tasks, it's a much simpler thing for you to grok, because once the tasks are sort of tasked out in small chunks, it's very understandable to see, kind of one change at a time. What was changed? How did it change? You don't need to have 15 minutes of mental model construction to understand it, right? But that only happens because you're changing the way you do work kind of foundationally.
Yes, and the other thing about that, and I think that it's starting to finally cross the chasm between engineering and product and sales, et cetera, and that is by allowing the engineers to move more towards a complete functionality perspective. This is what I want it to do. This is what I want it not to do. This is as much more than this is how it should work. This is how these things should be optimized. It allows the conversation to focus much more on, are we achieving what we're supposed to be doing? The software is not the end be all, right? The software is something facilitates your organization doing something, right? And that level of abstraction now, what we're seeing is for the first time, I think, we're really able to take a step away from the details of the technology and take a step towards what the functionality is that we're trying to accomplish, which rolls back into the measurement we were just talking about, in terms of, are we achieving things that are demonstrable and visible to the end user, the consumer of the applications?
And that has two, I think, big implications. Completely agree with you. So the first implication is, I was talking to a really senior engineer recently, and we were talking about kind of, are you doing the best you can with these AI tools? Like, are you operating at maximum value? Like, are you getting maximum, juice out of these limits? And the answer is no. If we're being honest, the answer is no. And then the next question is, well, what are you doing about that? And if the answer is nothing, then you're not really living up to your end of the bargain, as far as your value isn't to write code. Your value is to produce valuable software. And they're not the same thing. And you now have a effort multiplier. But if you're not responsibly using it or changing the way you work to get more value out of it, then I don't think you're living up to your end of the bargain. I think as engineers, we all have to come to grips with, I got to do something different than what I was doing before to get max value out of this, because that's ultimately that's what I'm supposed to be doing. I'm not supposed to be measured by how many lines of code I write or how beautiful my code is. That's important. But what's more important is, how much value did you actually generate?
Absolutely. And again, the paradigms are shifting, and the people who are in the traditional engineering roles are in a very precarious place, because first they've been told, you need to use this new technology, and they assumed it was to help them code. And the answer is, no, you need to use this new technology to help us get functions and features out quicker.
Right.
And while that seems like, oh, no, duh, that's of course what we're supposed to be doing. On a day-to-day practical, what am I doing for the next 45 minutes? That's not very obvious to a lot of engineers, at least ones that I know. Right?
Yeah, I think it's a universal issue. This is, and I mean, at the risk of belaboring the point, this is why I think tools like spec-driven development are so valuable. It's not that they're amazing tools that are doing something miraculous. They're just codifying into your normal practices, day-to-day things you're going to do as an engineer, concepts that help you get more leverage out of AI. That's what they're for. That's what they're doing. Right? Like the basic idea of, you figure out your requirements, you figure out your plan, you figure out your tasks, and then you have the machine execute the tasks. That's there because that's how you get max value out of this thing, not because it's some amazing, clever way of doing it. By the way, the other big implication for all this is, there's no reason for an engineer to plug in, or you can have other people plug into that process that help the engineer. You could envision your product people participating in the same sort of a dance, in the same sort of a cycle, with the same kinds of tools to help you figure out the requirements, write the plan, especially with the aid of Claude or whatever sitting on top of a code base, helping them figure it out.
But that ties right into one of the other points that came up, I think, in the presentation, and that is, small teams seem to be much more effective at the moment adopting AI than large teams. And my belief for that is twofold. First off, is you can be way more efficient with a smaller team because your communication channels are much easier.
Surely.
But the other thing is, small teams can adapt. and they can
Sure.
throw everything out the door, and 6 people can quickly do things completely differently and integrate themselves starting from the ground up in ways that larger teams or larger departments can't.
No
And I
question
think
about it. And that's kind of a superpower. I mean, it's always adaptability has always been a superpower of small teams and startups, right? That's why they exist. Because otherwise, why would there ever be a startup or a small team? You could just have the big guys do it. But that adaptability is a superpower, and I feel like with AI, it could be leveraged even more than it normally is.
it could be. My thinking is though is that just like the engineers need to start thinking about how can I leverage this new tool, this new technology to get features out, because that is the new metric that I'm being held to, that which means I have to learn more about how to use it and adopt it, et cetera. But going a step up into the larger corporation, how can the corporations get themselves to the point where I have an engineering team, but really we need to break these things up into smaller teams. We need to be able to do other things. We need to, forget product and engineering. I need to said, I'm going to have 12 startups in my organization. I don't know, but there's going to be a fundamental change for the companies that really leverages properly, I think.
Well, just to remind our listeners, this is a podcast for CTOs by CTOs. And I think if there's a job that a CTO in the modern day in 2026 has to become aware of very quickly, it's this exact thing. How do you make AI maximally valuable to your organization, and what organizational changes do you need to actually get across to make that possible? Because again, I don't think this happens organically. To your point, you need leadership here. That's
absolutely.
That's where I feel like our kind comes in. That's what,
yes, and there's a lot of variations to that as well. I mean,
surely.
You can understand this, but it's got to be done within the context of whatever the organization is, right?
Sure,
this is not the same for people who are doing things like HIPAA compliance versus people who are doing things like scheduling evites kind of stuff, right? So there's a lot of variability on what's important to it. But you're right, it's a fundamental change that's organizational. But I think also, product and engineering a lot of times go very high up the food chain before they intersect. And getting that level of buy-in is something that's, I think, is going to be a big change for a lot of companies.
But to that point, I firmly believe that it is not purely an engineering thing, because you could have the best engineering team being most productive, or the most productive it can ever be with AI. If the rest of the organization hasn't adjusted to that, I don't think you get maximum value anyway. So
absolutely. And that, yes, to my point. The larger organization has to embrace this, and it could be we need to take the org chart, throw it in the shredder, and come back with something that works within this paradigm.
I feel like a consistent theme last year around all these product conversations is the lines are blurring so much between product and and engineering that, like, at some point, I feel like it'll become counterintuitive to have those be reporting into different parts of the organization or have different sort of marching orders, because the worlds are colliding. Like, it's just blurring at a very high rate of speed. But
I think the most logical thing, and this is purely a guess, but in my experience, it's hard for structures to change, but responsibilities can be rather fungible. And I could see various traditional responsibilities moving across the line to a different group in an effort to try and make it that way. So, for instance, in product, you can have them really focus customer out and keep the requirements high level, or you could go the other direction and have them making proto software that you have the engineering team taking to production quality. I don't know how it'll ultimately play out, but I can see that kind of variation happening before companies come back and say we now have Prodeng, and it's all of the stuff, and it goes up to the CTPMO, and
Yeah, no, yes, I totally hear you. It's going to be different by organization, because obviously people still matter, skills still matter, and different organizations have different combinations of them. But yes, one way or another, there's got to be some kind of reconciliation here, because yes, these things are just colliding. Whether you want it or not, they're colliding. So it's either you embrace that collision or you get really hurt by it. But
yeah, I mean, to kind of summarize it, a lot of these failures that we've seen over the last 12 months or so, it's not because AI screwed up. It's because you screwed up in how you used AI.
Yeah. Yes. And on that cheerful note, I think that concludes first podcast of this new season and this new year. Well, if you found the topics we discussed today interesting or relevant to you, LA CTO Forum has lots of opportunities to engage with other CTOs about topics just like this one. And if you're interested in learning more, find us on LinkedIn or on the web at lactoforum.org. Until next time, may your deployments be smooth and your tech debt manageable.
And remember, if you can't handle the exception, at least log it properly. We'll catch you next time.